Bismillahirrahmanirrahim. I am Najibullah along with my groupmate Sahib Akil. So we are going to present our FYP presentation, Design and Implementation of Distance Relay for Transmission Line. In this presentation, we will first talk about introduction, then we will go to motivation, then problem statement, then literature review, then aim and objective, then methodology, then we will discuss results and discussions, then conclusion, and future recommendation, and then inferences. Basically, our project is about design and implementation of distance relay for transmission line for laboratory purpose in power system lab. And these distance relay are used to detect fault in transmission line and to determine the distance of fault from the installation point of the relay. Actually, distance relay work on the principle of impedance. So the impedance of transmission line is uniformly divided over its length. So for this reason, a distance relay can discriminate with a good accuracy between fault that is lie in its tripping zone or the one that is external to its tripping zone. What is the motivation behind this project? So as we know, transmission lines are the means of transmitting power from a generating source to various load center. So to maintain the reliability of the power system, protection of transmission line is of a prime importance. So to understand the distance protection and increase its efficiency, and also to equip our power system lab with distance relay trainers in order to analyze and observe the behavior of distance protection for transmission lines. So these are the motivations behind our project. So what are the problem statement? So as we know, transmission lines are the most vulnerable part of power system to the fault. So the unexpected changes in current and voltage may cause interruption in the flow of power in the system that might cause serious and irreparable damages. So it is very important for the system to react to a sudden undesirable changes to current voltages to maintain steadiness in overall performance of the system and to protect the damages caused by these changes. So one of the problem is also that our labs was not equipped with distance relay trainers to observe and analyze the principle of distance relay protection. So we are required to design a distance relay trainer.
Uh, as Najibullah mentioned in project presentation flow, that first step of our project was to literature review. In literature review, we have reviewed different literature about fault and about faults and distance relay. First of all, there are some research papers in which different types of fault are mentioned. And this author mentioned that there are symmetrical and unsymmetrical faults in our transmission line. Three-phase faults are considered symmetrical fault, and line to line, double line to ground, and single line to ground are classified as unsymmetrical faults. Now, the other author says there are 11 possible types of fault in the system that are different types of line to ground fault, double line to ground fault, and three-phase fault and three-phase to ground faults. Same is stated by this author. He also stated that there are different type of fault. The most severe fault, the three-phase fault, but the probability of occurrence is less, and this single-phase ground fault are very common in power system. Now here we are with distance relay. Then this author has said that the protection, there are different type of protection relays in which are used in power system, but impedance relay or distance relay is one of them, which is used to protect our transmission line. Nowadays, numerical distance relays have been widely used as the in distance relay protection to protect the transmission line. The other author says the different transmission line can be protected by the overcurrent relays, but they are not fast and coordinated as the transmission line is a mesh network. So in this, we use the distance relay to protect the transmission line. Now coming toward the working of the distance relay, that how distance relay work in the protection of transmission line. Actually, distance relay it can calculate the line impedance by measuring the voltages and current of single, and by measuring the voltages and current, it can provide the information about that the fault is at this distance or this distance. Actually, the length of the transmission line are distributed in different zones for the protection. Like this author says that zone 1 is about 80% of the length, uh, zone 2 is about 80% of first, in addition with 20% of the other length, and zone 3 is about both of the zone 1 and zone 2 plus 20% of the other length. Now, the aim and objective of the of our project was to design a distance relay trainer for laboratory purposes. Then the second objective is to make distance relay intelligent in such a way that it will determine the distance of the fault from the relay, and also the designing of protection zone for protection of transmission line. And now coming toward the results and the first step in designing the distance relay. Here actually the methodology, the literature review, then MATLAB Simulink literature review is reviewed, then MATLAB Simulink PROTEUS simulation, hardware selection, hardware testing, case designing, hardware assembling, final result, and result analysis.
Now coming to the result parts, first we did a MATLAB simulation, and MATLAB simulation first we designed a power system. In power system we take that components which are available in our labs as we are designing distance relay trainer. So we design a power system which have transmission lines of 80 kilometers. And then we design distance relay logic, then relay display and control panel in. So the transmission lines which we used in this project, which we are protected. So the parameters of these transmission lines are one. We have two transmission lines available which have the resistance 13 ohms, inductance 290 millihenry, and total impedance 92 ohms. And we consider it 35 kilometer. And the third one transmission line which have a resistance 3.3 ohms, inductance 80 millihenry, and impedance 25.5 ohms, and we have considered its length 10 kilometers. Now come to control and display panel of our Simulink model. So this is this portion show source voltage and current. This portion show transmission line voltage and current. This load voltage and current. And here from here we control the source voltage, and we vary from this part we vary load. And this give us the distance relay status. This give us a distance of the fault, and this give us a fault status of different zones, different phases in zones. And from here we generate faults in different zones. This is the distance relay logic. And distance relay logic, we take current and voltages during a fault conditions, then extract impedance, and we convert that impedance to distance, and then we compare it if the distance lies in a tripping zone. So the relay generate a trip signal, and according to the zone selection. So in this we did a zone selection that our relay will consider if the fault lies in the third zone, so it will take a delay of 750 millisecond. If the fault lies in second zone, so it will take 350 millisecond. If the fault lies in first zone, so it will trip instantaneously and generate a trip signal for the breaker. And this portion we have extracted RX diagram is RX diagram explain the characteristic of the distance relay. So here we take active power, reactive power, and then here we extract apparent power. So we take active power and apparent power ratio. So from here we extract power factor, and then we convert from power factor we extract reactance and resistance. In this normal condition, as you see, all current is normal, voltage is normal, and we have here from here it is the system is operating normally. So here we give three-phase fault in first zone. So three-phase fault, when we give three-phase fault in first zone, so the breaker is tripped instantaneously, and the relay show us from where the fault occur. This is the distance of the fault. And This is the scope view of the three-phase to ground fault. In this, as we see, in this is normal condition in which the system operate normally. Here, the fault occur and the relay instantaneously generate a trip signal and instantaneously isolate the faulty parts uh, and the isolated the fault. Here, we give two-phase to ground fault in zone one. So, the relay take 350 millisecond and then generate a trip signal. Then here we give single phase to ground fault in zone one. Then we give three phase to ground fault in zone two, and as we see, this show that the fault occur in zone two, and which type of fault occur? Three phase to ground fault occur, and these are the status. As we see, we have no current in the load portion. Here we see that when fault occur in the second zone, so the relay take 350 millisecond. Here the fault occur and the relay take 350 millisecond, and then it generate a trip signal. Here we give two phase to ground fault in zone two. So and the relay generate a trip signal. So isolate the fault. Here we give single phase to ground fault in zone two, and here we give three phase to ground fault in zone three, and you see that you can see the relay status. When we give three phase to ground fault in zone three, so you can see that here the system operate normally, and from here the fault occur and the relay takes 750 millisecond, and then it generate a trip signal. This is the RX diagram of distance relay. Here the fault occur at the verge of the first zone, so the relay generate a trip signal instantaneously and isolate the fault. Here the fault occur on the margin of second zone. So when the relay takes 350 millisecond in the trip signal. Here we can see that the fault occur at in the locus of second zone. So the relay generate accordingly a trip signal to second zone. So here the fault occur in the third zone. If the fault lies outside all the three zones, so the relay will not operate. If the fault lies in any of the three zones, then the relay will generate a trip signal and isolate the fault.
Coming towards the PROTEUS model, and the PROTEUS model in PROTEUS model we have designed a model of our distance as the replica of our hardware. In this we have mentioned that total transmission line distance is 180 kilometers with a total impedance of 75.314 ohms. Then this is our PROTEUS model. In this this part is about the current sensor. This is about the voltage sensors. These are the circuit breakers, and from these switches we have generated the different types of fault. This is a display which shows and the voltages and current and also about the distance. This is a microcontroller Arduino Uno in which the software is burned. Actually, we have used the Arduino in our hardware as well. So in PROTEUS, we have designed a software to actually check the reliability of our software, that it gives the actual values or not. So to operate, firstly we have give the single phase fault. In this, the switch of first phase is closed and the fault is generated. Here we can see the voltage of first phase is decreased and the current is increased. This is a distance that is shown by the microcontroller on the display in case of single phase fault. And then double phase fault, here that we can see that the voltages of the two phases is decreased and the current of the phases is increased. And then this is a distance which is shown by the display at which the fault is occurred. Similarly with the three phase fault, here we can see the voltages of the three phases decrease and the current is increased. And this is a distance which is shown by the display. And as we can see here, the point of fault is only one. So we have modified our Proteus model in order to give fault a different location to check the reliability of the distance lead, that it is actually giving us the accurate result of the distance or not. So we have modified our Proteus model. Head distance is 150 and with a total impedance of 30.18 ohms. And as we can see here, that there are different switches used, which is used to add fault in the transmission line. This is the normal operating condition. So first we have given the single phase fault. The single phase fault is given as we can see here, that the voltage is decreased and the current is increased in a huge amount. This is the distance which is shown by the display, which is 12 kilometer. Now double phase fault, we have given the double phase fault at another location. So we can see here that the voltages of the is decreased and the current is increased. And this is the distance which is change distance from the previous one as the point of the fault is changed. Similarly, with the three-phase fault, here we can see the distance, the voltages of the three-phase is decreased and the current is increased, and also the location of fault is changed. So the display gives us another location of the fault, which is 1.8 kilometer of the fault. This is the software flow.
First, in software flow, first our sensor read data from current and voltage sensor. Then we extract impedance from that voltage and current value during the fault. Then the extracted fault, we extract fault distance, and then we compare it with a set value. If the fault distance is less than the set distance, then it select zone. If no, then it again read the sensor current and voltage values. If yes, then the relay select a zone that in which zone the fault lies. If it lies in the first zone, so it will generate generate a trip signal instantaneously. If it doesn't lie in first zone, then it check that it lies in zone 2. If it lies in 2, then it take a delay of 350 milliseconds and then generate a trip signal. If it doesn't lie in zone 2, then it check if it lies in zone 3. If it lies zone 3, then the relay take a 750 millisecond delay, and then relay generate a trip signal, and then our program ends. In hardware selection, we have used current sensor voltage for current sensing, voltage for voltage sensing, then use LCD and microcontroller, Arduino microcontroller. Then we use a relay module of 4 channel for generating strip signal to the breaker. Then for case design, we use acrylic sheet, then USB port. We use the toggle switch, power inlet socket, and female connector, small and large. In hardware calibration, first we did sensor calibration for sensing of current and voltage. We also check display, etc. All the components we check one by one.
The enclosure of the distance relay hardware is designed on the SolidWorks. As we can see here, the SolidWorks is the very efficient software for designing the enclosure or any other type of the designing. So here we can see that this is the front or the front of the enclosure. This is the back of the enclosure, and this is the bottom of the enclosure. Then this is the left side of the enclosure. This is the top, and this is the right side of the enclosure. These all are designed in the SolidWorks, and then acrylic sheets are used in order to make it these SolidWorks model is then laser cutted on the acrylic sheet by the fabrication machine, which are available in the fab lab of our university. And this is the final assembled design, and here are the dimensions. And the length of the model is 298, whereas the width is 250. Now coming to the hardware assembling and testing, we have assembled as you can see that after fabrication of the enclosure, then this black is the front and bottom of the enclosure, and that different ports and Arduino and relay module with display along with the different sensors are are bounded in the front panel, whereas the Arduino and relay is in the bottom of the enclosure.
Now in hardware flow, we use power supply in our lab, then we use circuit breaker, then we connect to a distance relay, then we after distance relay we connect first transmission line, then we connect second transmission line, then we connect third transmission line, and then we connect load. So we have given fault in the first zone, second zone, and third zone, and check the reliability of our distance relay, that whether our distance relay is able to detect the fault or not. So this is our setup, our trainer setup, which we did for our distance relay protection. So in results portion, we give three-phase to ground fault in zone 1. So as we see in the display panel, so the our relay detect that in which fault the fault occurs. So the relay tell us that phase A, B, C to ground fault occur at a distance of 34.74 kilometers. So this is the this is the breaker from where we give fault, generate a fault, and this show that the fault is isolated. Here we give two-phase to ground fault, double phase to ground fault in zone 1. So this is the fault breaker. From the breaker we generate a fault. In display panel we can see the double phase A and B to ground fault occur. It also tells us the phase in which phase is the fault occur, and it also shows the distance that 34 point approximately 35 kilometer the fault occur, and this show that the fault is successfully isolated. Then we give single phase to ground fault in zone 1, and you can see that the breaker is stripped and the fault is isolated. And then we simultaneously we give the three-phase to ground fault, and then in zone 2, and our relay take a 350 millisecond delay and then generate a trip signal, and our breaker trip as we see the fault is isolated, and also tell us the distance that fault occur at 720.6 kilometer. And then we give double phase to ground fault in zone 2, and in display panel the phase is show the phase is shown that in which fault in which phases the fault occur, and from here we can see that the fault is isolated. And similarly, three-phase to ground fault in zone 3, we give three-phase to ground fault in zone 3, or relay take 750 millisecond delay and then generate a trip signal and isolate the fault. And we can see this is the fault breaker. From here we give the fault to the system. So now we give a double phase to ground fault in zone 3, and as the values are shown in the display. Then we give single phase to ground fault, and from here we give the fault, and we can see that the fault occur in third zone at approximately 80 kilometer, and phase A to ground fault occur. And from here we can see that the fault is successfully isolated, and the breaker is in off status, and we have no current in the power system. So this is our final distance relay trainer. So we can see the 3D view. In future recommendation will be discussed by Mr. Smith.
In future recommendation, we have to make the trainer more advanced, that it will detect all the possible fault that are running. Actually, we have worked only on the ground faults, and all the other types of faults are remaining. As the trainer is only work upon the short transmission lines, so we can extend our trainer from medium and long transmission line. We can make our trainer on IoT based by using different type of microcontroller like Raspberry Pi, etc. And last, we can commercialize our product to different universities for the laboratory purposes. This is a cost analysis of our project. Like we bought different sensors on this price and voltage sensor on this price, LCD, Arduino microcontroller, relay module, case designing, female USB port, toggle switch, power inlet socket, USB cable, jumpers, wire, long connectors and small connectors. The total cost of our project is this. The, and this was all about our project. At the last, these all are the references upon which we have studied our literature review, and these all are the references that are used in the presenting of our project, and as well as the thesis writing of our project. And these are the different the references that are used in our project. Thank you. This is Sohaib Akil and Najibullah signing off.
Thank
Take
you.
care and thank you. Allah
Thank you.
Hafiz.